Hi everyone, it's good to be here. Swati Club, Sabadi Mai to all the Thai people. It's a pleasure to be here. I spend a lot of time here in Thailand, and thank you to all the Thai people that are going to be listening to my English talk. I do have a British accent, and I'm from the UK, so you just have to get past that a little bit. So I am the founder of a company called RConnect, and we do community and open source. So you can find us at community events. You can find us on GitHub, contributing to major open source libraries. And there's various QR codes throughout this talk that you can scan, and it will take you to that various page. So the title of my talk today is going to be about, do you really need all that prompt? And it's kind of just like a reminder for people, if you're building tools with a large language model, do you really need to pass in all that prompts to the large language model? So we're building a tool that I'm going to showcase to you today, which is called the GraphQL plain text. And what it essentially does under the hood is it builds one giant prompt based off of the API schema, and then defers a response from that. I'm going to dive a little bit deeper into some of the problems we faced when building this tool and how we overcame them. So just a side note, anybody can work with AI. So nowadays there's MCPs, there's open source libraries, there's APIs. You just need an API key, and then you can start interacting with a large language model. So anybody who hasn't worked with an AI language model before, then now's your reminder to do it today. So GraphQL plain text is an open source library. It's on NPM and it's on GitHub, and it's maintained by RConnect. You can visit it by scanning this QR code. Oh, I'll just give it open a second more. Let me know if the QR code works as well, just somebody shout something if it does. So GraphQL, I'm not going to be talking about GraphQL specifically today, but I just want to let you know that it's basically an API with a schema. So the schema is on the left here. You issue a query which kind of corresponds to that schema, and then you get a response that looks exactly like that structure. And this is perfect for prompt building because you can essentially put this schema in the prompt, and then you can instead swap out the query for like a plain text string. And so what we do under the hood with the library is that we take the schema and this prompt, and then we defer the query using a large language model. So it's an open source SDK available to you to download from NPM. And you simply just pass in the type definitions here as this variable. You define which adapter you want to use. So this example, I'm using OpenAPI, AI, sorry. And then you have an interface that you can use to issue the plain text queries, and then it will give you the response, and it will basically generate that query for you using a large language model. And this is all possible via the prompt, and specifically injecting the schema into the prompt. So you can see here that this is kind of like pseudocode from our source code, is that we compress the type definitions, we put in your plain text string, and then we just give it a bunch of other context rules around GraphQL, to do with variables or comments or the structure of the GraphQL query that's generated. So this compressed type defs, we had one of our first clients on board to the library, and the second it got to any scale, basically our library just fell down because their schema was maybe 200 types or more. And this led to a ginormous schema. And so this string that we're generating now, it was huge. And sometimes it was even past the character limit of the large language models. So we needed kind of a better solution. And in fact, compressing the type definitions, so just removing the white space wasn't really enough. It didn't really satisfy coming under this character limit. And you can see here that this is like an extract of the GraphQL schema from GitHub. And it's huge. I mean, this is just like a tiny little bit, but you can imagine how many types go in there. And the second you try and use our library with the GitHub API, it took about 2 minutes to respond to any question that you asked it. So it wasn't really usable. So if you are building a big prompt, and specifically if you're putting in a schema in there, then you have to be really careful about this. It's going to take a lot of time to resolve your question. You have a higher chance of the LLM hallucinating, and it's less context aware. So we need kind of a better solution to this. So this is where Neo4j comes in. I know that the previous talk was about Neo4j, so I won't dive too far into that. But it is a graph database. It's perfect for mapping a GraphQL schema one-to-one, and it's really, really fast at traversing relationships. So there's one more point there, that it supports for vector embeddings, which I'll get into in a second as well. So Neo4j, it basically works with nodes and edges, as you may already know by now from the last talk. But here, we have the conference, I have myself, and I have a talk, and we can derive various queries from this graph, such as find me all of the talks at the conference. So if we circle now back around to the tool, in that we provide the schema, first of all, well, we want to actually add a layer in front of our prompt generation using Neo4j. And to do this, what we need to do is take our schema, and here's some pseudocode highlighted in yellow. And basically for every single type, so type logging, type user, so on and so forth, and all the fields, we basically create a vectorized embedding into Neo4j, and we store that schema as a one-to-one mapping in the graph database. And so here's just some Cypher, the query language, and it's basically set in the embedding. And the embedding is basically just like a jumbled up representation of that type. And it looks something like this. So now we can start to actually query what's on our schema and how different fields and different types are related to each other. So if we go back to the initial, which was, let's give a plain text question, let's give it a schema, and let's get a generated query as a result. Well, what we actually want to do first, instead of sending our entire schema to the large language model, let's actually use some of the existing technologies that have been around for quite some time, including the full text search, fuzzy search, vector embeddings, and let's get a subset of this schema that is relevant to this question. And so we can use Neo4j for that. And this is what we ideally would like to send to the large language model, not all of this. And we can do that quite simply with Neo4j. So Neo4j has some graph data science libraries, and you can basically compare the embeddings that we created just previously against the plain text string. And this is going to do a similarity search, and it's going to return all the nodes and all the types in that graph that are relevant to that plain text string, which wherever it is here. And then that will give us like a partial schema, a bunch of nodes and arrays and stuff like that. And what we can do is, well, this is what the query looks like, essentially back on that graph. So we just find the relevant parts. And then essentially we have a layer which pretty much sits here in this diagram, the Neo4j layer, and we convert the plain text string into a subset schema, and then we pass that directly into GQL-PT, which is GraphQL plain text client. So do you really need all that prompt? There's a lot of other solutions out there for you, including vector embeddings, fuzzy search, full text search that you can use in front of your prompt generation, because you shouldn't really be using the large language model to be filtering data for you. So if you're interested in this, or if your company needs a plain text interface on top of your API, then you can visit apipt.dev. And this is what we're working on in the background. It has a lot of intelligent features such as workspaces, caching, versioning, and security, and so on and so forth. And if you're curious about why you might need something like this, then there's a bunch of use cases. A lot to do with admin panels and chatbots and so on and so forth. So thank you every one for your time today. And if you have any questions, then just let me know. Thank you. Any questions? Okay, Hop and Cup. Go ahead.
So I guess like thanks for the tool. Looks good, but my question is, what trade-offs do you see when you use your proposed format? Are there scenarios where it is not so appropriate or you don't get the performance that you're looking for?
Well, so it really depends on the scale of your schema. So there's a lot of tools out there that do AI to SQL. And basically these AI tools will take your entire SQL database and then just give it to a large language model and expect to kind of derive context from it. But with this tool, you have full control of the API. So you can give GraphQL plain text any API that you build yourself. That includes security in front of it. You particularly explicitly say which fields should be available. So it's kind of down to you in the scale and the way that you use it. Thank you, everyone. Cotton Cup.